Hearing will come to order. I want to welcome the members of the subcommittee and our distinguished panelists to today's hearing on hybrid technologies for medium to heavy-duty commercial trucks. With concerns about our over-reliance on foreign oil, the skyrocketing costs of fuels, and the effects of our transportation sector on air quality and carbon emissions, technological strides in the commercial truck market stand to offer tremendous benefits to our economic and environmental health. Though it's easy to overlook, these vehicles are pervasive throughout our economy. From school buses to trash collectors, utility trucks to delivery vans, long-haul tractor trailers to road work equipment, one would be hard-pressed to identify an aspect of our daily lives that didn't at some point depend on medium to heavy-duty trucks. They also represent a substantial portion of the U.S. fuel consumption and emissions. The truck industry is due for a major technological shift, but advances in this sector don't come easily, and there is no one-size-fits-all solution. The demands on these vehicles are as varied as their uses. Consequently, there remains a need for a robust federal program to partner with industry and develop this wide range of hybrid platforms. The focus for hybrid vehicle technology development has largely been on passenger vehicles. Passenger vehicles have paved the way both in terms of advancing the technologies and expanding public awareness of capabilities of hybrid systems. You need only to visit your local dealership and see the waiting lines and lists for hybrid models to know that the general public is serious about saving fuel and reducing emissions. There's a larger market for hybrids beyond the family automobile. Reducing fuel costs and meeting environmental regulations is vital to the bottom line of any company that relies on heavy trucks. Yet the administration has chosen to shift resources to the passenger automobile and away from its 21st century truck program. Given the significant gains to be made in the commercial truck sector and its indispensable role in our economy, we should ensure that federal research and development programs continue to address the need to improve fuel efficiency of heavy-duty vehicles. We're joined by our colleague, Mr. Sensenbrenner, ranking Republican member of the Investigations and Oversight Subcommittee, who will soon introduce legislation to enhance the federal role in the development of heavy hybrid vehicles. I would like to thank him for elevating this subject to the level that it deserves, and I look forward to the opportunity to consider his legislation at the appropriate time. And at this time, I would yield to my distinguished colleague from South Carolina, our ranking member, Mr. Inglis, for an opening statement.
Thank you, Mr. Chairman, and thank you for holding this hearing. Transportation needs innovation. The transportation sector is our primary consumer of oil and exhales more carbon dioxide emissions than any other source. The more we pay at the pump each week, the easier it is to realize the obvious benefits of alternatives to oil. It seems that rising oil prices rouse our attention to ways that we could do energy a different way. This hearing is a case in point. In previous hearings of this subcommittee, we've talked about reinventing the car. We've heard the economic, environmental, and national security benefits that will accrue to pursuing hybrid battery and hydrogen technologies to power tomorrow's cars. Today, we'll hear from a number of experts about the medium and heavy-duty commercial truck market and its needs for the same innovative focus. Applications such as hybrid engines and battery-powered auxiliary systems promise a significant reduction in oil consumption and greenhouse gas emissions. But technological hurdles stand in the way of realizing those benefits. I join with the chairman in thanking Mr. Sensenbrenner for introducing this draft legislation that would steer federal dollars toward research, development, and demonstration in the areas of commercial truck hybrid technologies. I'd be interested to hear from our witnesses as to whether current oil prices are enough incentive for heavy truck companies to invest in these technologies, or if there's a necessary role for the federal government to assist in overcoming these technological hurdles. Thank you again, Mr. Chairman. I look forward to hearing from our witnesses on their perspectives on this legislation and suggestions as to ways we might improve it.
Thank you, Mr. Inglis. And now I would like to recognize Mr. Sensenbrenner for a statement.
Thank you very much, Mr. Chairman. New taxes are not the only solution to climate change. We need to focus our economy as we work to reduce our emissions. We can overregulate our businesses, cripple our economic development, and watch as China and India race past us, sputtering greenhouse gases along the way. Or Congress can create incentives that encourage the development of new technologies that will reduce our emissions foster economic development, and allow U.S. manufacturers to export their energy-saving technologies worldwide. A honking motorcade of trucks around the Capitol last month flashed signs that read, "When trucks stop, America stops." Commercial traffic is truly vital to the American economy, and the fuel cost for trucks directly affects costs for all Americans. The additional price of their fuel raises the price of our food, health care, manufacturing, retail, waste removal, and the other goods and services. And while our economy would not survive without them, trucks consume huge quantities of oil, which raises the cost of their businesses, increases our dependence on oil, and injects greenhouse gases into the environment. The answer is not to burden these businesses already strained by high fuel costs with additional taxes for the CO2 they release. Instead, we need to encourage the development and introduction of technologies that will reduce their fuel consumption. Technologies we need already exist. Everybody has seen hybrid cars. This technology, which combines gas and electric motors for a powerful and efficient engine, is even more practical in trucks. Even though there are fewer trucks on the road, trucks use more fuel. Utility trucks, for example, typically drive short distances to and from a work site, but sit idle for hours while on site. A plug-in hybrid truck would use less fuel getting to and from the site and would operate without any fuel on the site. Ultimately, a plug-in hybrid engine in a utility truck could use up to 60% less fuel. Delivery trucks constantly stop and go. Hybrid engines excel at this type of driving because the engine can essentially turn off during short accelerations while coasting and while it is at a stop. Developing these technologies will have benefits beyond fuel savings. By making our trucks more efficient, we will make our goods and services more affordable and then become leaders in these new technologies. Like America, Asia is faced with rising fuel costs. Their trucking fleets, like ours, are currently powered by diesel. In Europe, the price of diesel has risen to nearly $9 a gallon. This has led to a strike. Spanish truckers are currently holding a snail protest, essentially blockading the highways of Spain and southern France by inching along the road. Anti-protest demonstrators, fearing that food and other goods could become scarce, have rebelled violently by slashing trucks' tires and smashing their windshields. If America's companies are the first to develop and commercialize products such as the topic of the hearing today, not only can we avoid a similar fate, but we can export these technologies worldwide. By helping American manufacturers research and commercialize new technologies, we can strengthen our economy, reduce our dependence on foreign oil, and lower our emissions. The legislation we will discuss today is a narrow example of how technology, and not taxes or carbon offset credits, can help solve our energy crisis. The legislation would accelerate research of plug-in hybrid technology in trucks by creating grants for manufacturers to build, test, and sell plug-in hybrid utility and delivery trucks. The Act would also encourage the Department of Energy to expand its research in advanced energy storage technologies to include heavy hybrid trucks as well as passenger vehicles. This bill will put plug-in hybrid trucks on the road and help advance research and accelerate commercialization of this important technology. I thank the Chairman for holding this hearing and the witnesses for lending their expertise to this effort. Back the balance of my time.
Thank you, Mr. Sensenbrenner. I ask unanimous consent that all additional opening statements submitted by the committee members be included in the record. Without objection, so ordered. It is my pleasure to introduce our witnesses this morning. Penney is the Technology Manager for Advanced Vehicle Technologies in the Renewable Fuels Science and Technology Directorate at the National Renewable Energy Laboratory. Mr. Eric Smith is the Chief Engineer for Medium-Duty Hybrid Electric Powertrains for the Eaton Corporation. Joseph Dalum is the Vice President of Dueco. And Ms. Jill Egbert is the Manager of the Clean Air Transportation Department at the Pacific Gas and Electric Company. Parish is the Senior Program Manager of the Hybrid Truck Users Forum at Calstart. You'll each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you all complete your testimony, we will begin with our rounds of questions. Each member will have 5 minutes to question the panel.
Thank you, Mr. Chairman, and other members, for this opportunity to talk about the status and potential of heavy hybrid trucks. NREL has been working for the last 15 years with partners in government, other national labs, and industry on both light and heavy-duty hybrids. Despite the tremendous progress that has been made, I believe that targeted R&D and purchase incentives are still needed so these trucks can grow in volume and play a prominent role in the marketplace. Primarily because of escalating fuel prices and tougher emission standards, the cost in operating and producing heavy-duty vehicles are rising at alarming rates. But there are reasons to be optimistic, despite the fact that more fuel is being used by our light-duty car fleet, and we're working hard on those vehicles too. We should not ignore advanced heavy truck technologies across many applications that can also significantly reduce their fuel use and subsequent emissions. To frame the opportunity, first a little background. About 80% of all our goods are transported by truck. And last year, Class 1 through Class 8 trucks consumed about 40 billion gallons of diesel fuel. The good news, hybrid trucks in various forms, from research prototypes to recent early commercialization products, have demonstrated the potential to reduce fuel cost anywhere from a few percent to 50 to 60%. Original equipment manufacturers, OEMs, and truck owners are learning that their exact savings depend on three things: the application, the duty cycle, and the way it's driven, and of course the distance it travels between stop and go. For example, a typical delivery truck using a hybrid drive system could save more than 1,000 gallons of fuel per year. In comparison to a conventional truck, we believe almost every truck application can benefit from hybrid drive of some sort and other system improvements. In addition to NREL's fleet testing, we have shown that hybrids' overall operating and maintenance cost per mile can be lower too, in part because of fewer brake replacements and less downtime, which help lower the cost differential between conventional and hybrid drivetrains. Let's quickly review the potential for hybrids and or perhaps plug-in hybrid truck applications by class. And if you have my testimony in front of you, take a look at page 2 and page 3, where I describe the classes 1 through 8. And you'll see that class 1 through 4 are your typical minivans, utility vans, pickup trucks. 5 includes a shuttle or a city delivery and a bucket truck. Class 6 is a beverage or a school bus. Class 7 is refuse haulers, furniture delivery, city transit buses, for example. And of course, Class 8, dump trucks, cement trucks, and line haul semis. Of course, military vehicles of all classes and sizes could also benefit from hybridization. And several have already been demonstrated, as you are well aware. I'd like to draw your attention to the Class 8 trucks. They use, and this is on page 3, you'll notice that they use as much diesel fuel as all other truck classes combined. And until recently, many believed there was little hope in hybridizing line haul semis because they don't have much stop and go, which is classic of the hybrid cycle. However, even in this class, truck OEMs are finding opportunities for fuel savings, even if only in the single digits. Because hybridization and other system improvements can yield tremendous savings. Today, hybrid trucks are just starting to hit the market in various service applications, most notably transit buses, though for most applications it's a tough sell. This is probably because the cost premiums which result from limited current production quantities and the need for further improvement and establish the system reliability, economics, and performance of various truck components. Along with continuing credits and incentives, we need to continue our R&D programs to improve the performance and economics of these hybrid systems. The National Academy of Science recently completed a detailed examination of the 21st Century Truck Partnership projects in this area, and that report is expected to be delivered to the Department of Energy in the next few weeks. I would encourage you to review its findings. There are approximately 18 million commercial vehicles on the road. Every kind of vehicle represents a different set of demands, and these in turn determine vehicle size, configuration, and each with a different duty cycle. As a result, there are many unique powertrain solutions. A hybrid is not just a hybrid. Today, there are a handful of demonstration hybrid trucks, many supported by federal and state cost-sharing programs, and are shedding life on both opportunities and challenges. But production volumes are still very low and not very high. Since system costs from drivetrains through energy storage systems to power electronics must be continued to be reduced. So with these considerations in mind, what needs to be done? First, we must understand the unique duty cycle of the hybrid vehicle. Then we need to understand how these new powertrain topologies can boost miles per gallon or ton miles delivered. We must take an overall systems approach to greater efficiency. We also need to work on advanced combustion, heat recovery, energy storage technology, especially batteries and ultracaps, to improve the cost, performance, and life, and thermal abuse tolerance. Finally, we need to improve the overall performance and cost associated with the power electronics module and electric drive motor, improving performance, life, and reliability issues through advanced thermal control. Despite a limited DOE budget, the DOE Vehicle Technology Program is actively engaged in pursuing many of these technical areas. With DOE's support of NREL, we employ heavy hybrid vehicle R&D testing, analysis to understand and solve many technical issues and overcome these barriers while working with OEMs and their suppliers. For example, NREL's Refuel Lab tests advanced fuels in in heavy-duty engines for advanced heavy hybrid vehicles and is home unique testing and measurement equipment. With industry partners, we also conduct field evaluations of transit buses, trucks, idle reduction technologies. We design test plans, gather on-site data, and publish our results. Education, getting the word out, helping industry and fleet owners learn about what actually works and doesn't has been a hallmark of our efforts. The government's commitment to finding solutions for supporting advanced R&D and government industry partnerships and by encouraging incentives is absolute key. Thank you so much.
Thank you, Mr. Penney. Mr. Smith, you're recognized for 5 minutes.
Excuse me, we have over 28,000 employees in more than 40 states. A little bit of background on the Eaton hybrid power system. Following years of successful development and extensive real-world testing, Eaton is currently offering production hybrid electric products for commercial vehicle applications, and our first hybrid hydraulic products will enter the market later this year. Eaton's hybrid electric power system is currently in a production option in North America with Peterbilt, Kenworth, International, and Freightliner. And we're also working with leading European manufacturers such as DAF Trucks and Daimler Trucks. Eaton was part of the U.S. Department of Commerce Clean Energy Trade Mission to China, and we are working currently to place over 200 hybrid electric buses in Guangzhou, China. Those should all be placed by the end of 2008. The design and development effort for all of this work is happening at Eaton facilities in Michigan and Minnesota, and our hybrid systems are produced currently in Indiana and Iowa. Eaton has invested in 3 separate hybrid power solutions for commercial vehicles. First, our hybrid electric vehicle. Eaton's production hybrid electric power system can provide significant fuel savings and reduced vehicle emissions. Hybrid power is particularly appealing in classes 5 through 8 vehicles. These are large trucks with weights exceeding 16,000 pounds, such as pickup and delivery and utility trucks. And as you can see on my graph that is displayed here, the fuel savings possibles on the range of trucks we are discussing is not only from improved fuel economy while driving, but also from reduction in engine idle or engine off operation at work sites. Additionally, Eaton's hybrid electric power system is the only certified by the IRS for the medium and heavy duty hybrid tax credit that was enacted in the Energy Policy Act of 2005. I'd like to speak just briefly on the hybrid hydraulic vehicles. In addition to hybrid electrics that I've mentioned, Eaton is also working on the development of hybrid hydraulic vehicles for applications such as refuse trucks and pickup and delivery vehicles. We are working with the EPA and the Army to research and develop these vehicles. Finally, a few comments on plug-in hybrid vehicles. In addition to the hybrid electric and hybrid hydraulic vehicles, plug-in hybrid technology is in the early stages of development and demonstration for medium and heavy-duty trucks. Eaton is pursuing a number of development and demonstration projects directly and with partners such as the Department of Energy. With this energy, the focus must not be only on batteries, but also on chargers and electrification of the accessories that will be critical to the success of this technology. A few comments on battery system development challenges. The success of the hybrid market is tied to the development and commercialization of state-of-the-art lithium-ion batteries. The developed manufacturing and assembly methodologies needed to allow for the wide range of vehicle sizes and unique configurations needed in the world of, the wide range of vehicle size and the unique configurations needed in the world of medium and heavy-duty trucks. Remember, the benefits of hybridization apply equally to cars and trucks, although implementation and use in commercial trucks has unique challenges because of the size of the systems, the operating environments, and the duty cycles. Finally, the hybrid truck market and supporting technologies are still in the early stages of commercialization, and long-term leadership will be hotly contested worldwide. U.S.-based companies are currently positioned to be world leaders in development and manufacture of hybrid systems, and we can provide the same benefits and solution for truck fleets around the globe, but we must keep pushing our research efforts forward. As the committee debates funding research and development for hybrid vehicles, we would urge that hydraulic hybrids, and plug-in hybrid systems for commercial vehicles be included in any such programs. Once again, thank you for this opportunity to appear today in front of this committee as a representative of Eaton Corporation.
Thank you very much, Mr. Smith. Mr. Dalum, you're recognized for 5 minutes.
Good morning, Chairman Lamson, Ranking Member Inglis, and distinguished members of the subcommittee. Thank you for inviting me here today. Also, thank you for the opportunity to offer the views of Dueco and for soliciting the views of others on hybrid technologies for medium to heavy-duty commercial trucks. My name is Joe Dalum, and I'm Vice President of Dueco. Dueco is headquartered in Waukesha, Wisconsin, is one of the largest final stage manufacturers of utility trucks in the country. We produce aerial devices, digger derricks, and cranes that are sold to electric utilities for the maintenance of their transmission and distribution power lines. Dueco also provides equipment and services for the telecommunications market, other industries, and the government. In 2006, Dueco began to assess alternative hybrid vehicle technologies. Those activities led to a collaborative development program between Dueco and Odyne Corporation. Odyne is a developer of plug-in hybrid electric vehicle powertrains for Class 6, 7, and 8 vehicles. Our efforts resulted in the introduction of the utility industry's first pre-production plug-in hybrid medium-duty truck in the fall of 2007. While you've already received my more extensive written testimony, this morning I will focus on our development of a plug-in hybrid medium-duty truck. There are several factors that favor the development and deployment of hybrid and plug-in hybrid trucks. Rising fuel prices, increased pressure for environmentally friendly and green operations with lower carbon emissions, a national priority to reduce foreign oil dependency, and increased maintenance costs. In our company's opinion, plug-in hybrid technology for medium and heavy-duty trucks is particularly well suited to addressing those challenges. In my written testimony, you will find a more detailed explanation of the factors that support that position. I will now discuss our experience with a plug-in medium-duty truck. A photo of a plug-in medium heavy-duty truck is shown on the screen. This type of truck is typically used by utilities for the maintenance and installation of power lines. It is unique in that a very large battery system of approximately 35 kilowatt hours, more than 15 times larger than one used in a conventional hybrid, provides power to help propel the vehicle along with the diesel engine. The battery system also provides power for equipment on and off the truck. When the truck returns to the garage, domestically generated grid power recharges the battery system, offsetting the need for petroleum. The size of the battery system and the ability to recharge using grid power differentiates the plug-in hybrid system from a conventional hybrid. Using a large grid rechargeable battery system reduces fuel consumption and emissions during driving and provides for an all-electric stationary mode. The system completely eliminates fuel consumption and emissions at the job site for a typical day while also reducing noise. Fuel savings and corresponding reduction in greenhouse gas emissions are dependent upon the application. The current vehicle reduces fuel consumption by an estimated 1,400 gallons of fuel per vehicle per year for a typical utility application. I'm confident additional research can further improve fuel savings. In my opinion, there will be a time in the future where an affordable plug-in hybrid system for a medium or heavy-duty truck provides 100% electrical operation for unlimited driving range, completely eliminating fuel consumption and reducing emissions when recharged by clean electricity produced through renewable or non-emitting domestic energy sources. There are several technical hurdles to the deployment of plug-in hybrid trucks. Battery system cost and performance challenges, non-optimal powertrain architecture, questions about utility infrastructure for charging large fleets of trucks with high-capacity battery systems, and a lack of information about specific medium and heavy-duty applications need to be overcome. Dueco encourages the federal government to develop programs that help to specifically fund research into the development of plug-in hybrid systems for medium and heavy-duty trucks used in specific applications that are open to final stage manufacturers and other entities. Assistance with testing, certification, the creation of tax incentives for customers, and modification of government purchasing policies to favor the acquisition of more fuel-efficient trucks using plug-in hybrid technology can also accelerate development and deployment. Commercial fleets consume large amounts of fuel. Developing more efficient trucks that utilize domestically sourced power from the nation's energy grid would have several benefits. The development of this technology in the United States would provide opportunities for job creation, export opportunities, reduce the cost of businesses competing in a global market, reduce greenhouse gas emissions and emissions of other pollutants, reduce dependency on foreign oil, reduce noise within our cities, and potentially improve productivity for certain applications, such as electric crews who could perform work at night in residential areas. This is potentially an historic opportunity to develop the technology needed for the electrification of medium and heavy-duty trucks. I would ask for your support of the proposed legislation that would help to accelerate research into plug-in hybrid technology for medium and heavy-duty trucks and encourage the development of partnerships between manufacturers and utilities. Thank you.
Thank you, Mr. Dalum. Ms. Egbert, you're recognized for 5 minutes.
Good morning, Chairman Lanston, Ranking Member Inglis, and members of the committee. I am very pleased to appear before you this morning on behalf of Pacific Gas and Electric Company to offer my views on the important role of medium and heavy-duty hybrid and plug-in electric hybrid vehicles. Pacific Gas and Electric Company, headquartered in San Francisco, California, is one of the largest natural gas and electric power utility companies in the United States. The company provides natural gas and electric service to approximately 15 million people in northern and central California. For nearly 2 decades, PG&E has also actively worked to advance alternative transportation technologies, including natural gas and electric vehicles. We are particularly enthusiastic about the incorporation of hybrid and plug-in electric hybrid medium and heavy-duty trucks into our fleet. We have already seen tremendous financial and environmental benefits from doing so. The 2 most common uses for integrating hybrid and plug-in hybrid electric trucks into our fleet are for our so-called trouble trucks and more familiar bucket trucks. PG&E's trouble trucks are used by our first responders when an outage or other situation is initially reported. These trucks operate within a wide range of mileage parameters, ranging from a few miles if operated within the city of San Francisco to covering long distances if operating in more remote parts of our service territory. This range of operation makes hybrids an ideal solution for our company and our industry. For most repair work, the utility industry standard is to dispatch large diesel-powered bucket trucks. These trucks are then required to idle for long periods of time to complete many necessary repairs, consuming 1 gallon of diesel per hour of idle time. The idling is necessary to maneuver the bucket used to hoist servicemen to perform repairs. In 2007, PG&E became one of 14 utilities across North America to deploy one of 24 diesel-electric hybrid bucket trucks developed by the International Truck and Eaton companies. PG&E's field trial for this new truck is currently ongoing in San Francisco, and preliminary results indicate that diesel-electric hybrid bucket trucks reduce fuel consumption by 40 to 60%, reduce emissions by 50 to 90%, provide onboard power generating capacity to power up to 5 average-size homes while service is being restored, improve operational and scheduling flexibility, and reduce maintenance costs. In addition to incorporating these and other new vehicle and truck technologies into our fleet, PG&E has actively participated in DOE-sponsored workshops by providing a utility company perspective on the benefits and potential of all types of plug-in hybrid vehicles. Even as new technology demonstration options are becoming available to PG&E at an increasing pace, there remain significant barriers to our ability to more fully deploy the hybrid and plug-in hybrid electric medium and heavy-duty trucks, the most significant being financial barriers. Currently, the upfront cost of a hybrid bucket truck is 50% higher than a conventional bucket truck. In other words, we could purchase 3 conventional bucket trucks for every 2 hybrids we purchase. Though the lifetime fuel and maintenance savings help make the investment more attractive and the environmental benefits are a key part of our business objectives, the upfront costs are still daunting. In order to accelerate the procurement of hybrid trucks into utility fleets, we believe some financial incentive will be needed in either the form of grants or tax credits. These financial incentives would spur demand from PG&E and other utilities around the nation that will allow truck and power system manufacturers to ultimately bring down their unit costs. At a time of historically high diesel prices, increasing concerns over climate change, and energy security, the time is right to accelerate research, development, and deployment of hybrid and plug-in hybrid electric truck technologies. With thousands of utilities nationwide, the market for medium and heavy-duty hybrid and plug-in hybrid electric trucks is very significant. PG&E commends the subcommittee's inquiry into this important market, and we are hopeful that with effective government leadership, the right incentives will be implemented to help reduce the financial barriers that currently exist and that discourage widespread rapid deployment of clean hybrid commercial truck technology. On behalf of Pacific Gas and Electric Company, I want to thank you for the opportunity to appear before the subcommittee today. Thank you.
Thank you very much. Mr. Parish, you're recognized for 5 minutes.
Thank you very much. I'd like to thank the subcommittee for inviting Calstart here today to present our viewpoint on heavy hybrid technology. We feel like we serve a very important role in implementing this technology into the general public, and then also providing a means to focus the activity and the interest of the different fleets in producing these types of technologies for use in the fleet activities. I'd like to draw your attention to my presentation charts that are on the screen. The Calstart activity is based, it's a nonprofit organization, a consortium of not only industry but also fleet providers that is very interested in improving the industry, the transportation industry, and moving it forward in terms of decreasing the amount of fuel used and decreasing the amount of emissions that are produced by the commercial industries. HTUF, the Hybrid Truck Users Forum, is actually a subset of the Calstart activity and is a user-driven process in which we represent the fleets and try to bridge the gap between the technology development activity and the actual commercialization of these vehicles. HTUF intends to bring working groups together of fleets that are quite interested in a variety of different applications. Our first activity that we put together was in the utility bucket truck activity, which PG&E took part in. And we assimilated the different requirements from the various fleets to identify a common set of requirements that the truck manufacturers could then respond to. So what we did was get the hybrid truck technology off the ground. There had been some development of heavy hybrids in the Department of Energy, as well as the U.S. Army National Automotive Center and the Federal Transit Administration. But there was no real pull from the fleet side to actually get these vehicles into service. So what the Hybrid Truck Users Forum did was aggregate the requirements to provide a focal point for the industry to then start producing these vehicles. We did this in a joint activity with the U.S. Army National Automotive Center. They were very supportive of this particular activity because the Army is very interested in seeing the hybrid technology being implemented and being put out on the street so that they can see a reduction in the cost of these vehicles. Rather than footing the cost of developing this type of technology on their own, they would like to see it become commercially viable and therefore more cost effective in putting in the military vehicles. So we've been very active in terms of this first particular working group that we put together. We have looked at other working groups and are in the process of implementing those as well. Though you should be aware that hybrid trucks and medium and heavy duty trucks are very different than the light duty vehicles. We've seen a great implementation of light duty vehicles, hybrid vehicles in the public sector. There's good acceptance there now. But we feel like because of that acceptance, that the government should now start focusing on medium and heavy duty sectors to start making some real technology improvements and implementation of these new vehicle concepts. On this timeline, you see where there's a real range in implementation of these particular vehicles. On the far right, we're already in early production, as identified by Mr. Smith from Eaton Corporation. We're in early production of these bucket truck vehicles from International using the Eaton drivetrain. And that's very encouraging, but these vehicles are still rather expensive. There are other vehicles that are being implemented in terms of the refuse vehicles, parcel delivery, also shuttle bus type of vehicles that are going to be entering early production here in the next few years. But still, the technology is not there to implement some of the benefits that we see in the light duty world. In particular, I think it was pointed out that light duty vehicles have the ability to shut off their engines when they're at a stop, engine off at idle capability. Right now, we do not have that capability in medium and heavy duty trucks because we do not have the electrically driven accessories that are required. So much development is required in getting that type of technology in place. So we're seeing just the first versions of these vehicles emerging at this point in time, and much technology development is still really needed to make these viable. And as was pointed out earlier, hybrid technology is starting to be incorporated in Class 8 over-the-road vehicles, and now being looked at in drayage vehicles for the ports, particularly the ports of LA and the ports of Long Beach. And these are very promising types of technologies, but until we get the appropriate support for the technology development as well as the implementation of these vehicles, and then some incentives to help reduce the upfront costs, they'll be lagging in terms of their implementation. So, as identified, trucks are different from passenger cars, even though the technology has been well developed for passenger cars, and we see it starting to emerge. Trucks are a different order of magnitude in terms of their weight class and the scale of the systems that need to be put in place, as well as the durability that's required for these vehicles. So there's a whole new segment of development activity that needs to take place here. We feel that industry and the fleets could benefit from support for ongoing R&D. There was some preliminary R&D effort involved at the Department of Energy under the heavy hybrid program managed by the National Renewable Energy Lab, but that funding has been reduced and is now coming to a close. And but without the full benefit of coming to fruition for these new technologies. So we would like to see some further support for that type of R&D effort. And we also like to see that there be some purchase incentives. As was also pointed out, the initial cost of these vehicles is fairly high. The cost of the fuel at this point in time, even though it is high, does not quite cover the total cost of the differential cost of the hybrid vehicle. So what we're seeing is some additional funding needed up front to help cover that differential. So we'd also like to see a commitment by the government over a long-term 5 to 10-year program to really implement these technologies, not only hybridization, but also more efficient truck technologies into the commercial fleets. I'd like to thank you very much for the opportunity to talk with you today, and hopefully we have a good discussion.
Thank you, Mr. Parish. At this point, we'll open our first round of questions, and the chair will recognize himself for minutes. And Mr. Penney, let me ask of you, at what point in the development do you feel that it is appropriate for DOE involvement to begin to drop off? And secondly, should we focus only on the most basic research, or do we have a responsibility to see that technologies get to the market, and where are they weakest?
That's a good question. From my perspective, I enjoy seeing systems levels. When we work on components, which is essential and required, you sometimes don't, when you put all the pieces together, you learn new things. And I try to emphasize in my testimony that a systems approach is absolutely critical. Now, the Department of Energy is classically funded on the component level for energy storage, power electronics, thermal controls, and issues like that. They have drawn the line because they feel that industry's responsibility is to put that system level together. As was pointed out by Mr. Parish, we did have a few projects with Oshkosh Truck, with Eaton, and Allison bus transit fleets that system level performance really taught us new things that we didn't learn from just component type activities, and all of these companies benefited greatly by that education, and they would not be there today had it not been for that federal support.
Thank you. Mr. Smith, what is the price premium for an Eaton hybrid truck compared to a conventional model, and what accounts for the difference?
Well, the difference is accounted for because of the added componentry that we need to add. There's in a parallel system like we provide, there's a motor generator that's in the system. There's a power electronics inverter that takes energy from the batteries and feeds it to the motor, or in the condition where you're acting as a generator, such as regenerative braking, you're taking power back from the generator and feeding it into the batteries to recharge. So the price premium that you're paying is for all of the additional components, plus all of the controls that make all of these individual components work together, efficiently and safely. As far as the price premium, that's actually an OEM decision to the customer, since we sell to OEMs and then the OEMs sell directly to the customers. But as Ms. Egbert mentioned, the 50% premium currently on a hybrid vehicle is probably very close to what we're seeing out in the market today for a hybrid vehicle.
Has the 21st Century Truck Partnership been a success, and should it continue? And I'd like for all of you to comment on that, and add a second part to it. How could the program be structured better to speed hybrid technology in medium and heavy duty trucks? And you want to start, Mr. Smith, and
yeah,
others
actually,
who wants to?
Yeah, it's actually not a topic that I'm well informed on, and I can respond in writing at a later date to give a full response from the Eaton perspective.
Anyone want to comment on those two things? Please, Mr. Parish.
Yes. I think the 21st Century Truck Program ideally was very well conceived, and I think it started out with good promise, because we did have the involvement of a variety of different federal agencies in that particular activity, and it looked like it was going to be very constructive. However, as it turned out, I think it had limited success because there was a lack of a real vision and adequate funding for the activity. I think, as we've observed, the 21CT activity now is a kind of a gathering of interested parties that they're interested to see if anything is going to happen from the federal level. But from what we've seen so far, nothing has really been initiated, and there's been no real program activity that resulted as a result of the 21 CT program. So I would say that, yes, as it's conceived, it is a very viable and very worthwhile type of activity, but I think it needs to be revisioned in terms of how it's led and make sure that there's an agency that is very motivated to make it a success. And our association with the U.S. National Automotive Center has proven that they have the ability to.
Like a comment?
Yes, I'm NREL's lab rep for 21CT. In fact, I canceled my trip today. They're having a 21CT meeting at Volvo Corporation in Greensboro. And I think the issue, as was pointed out, there needs to be a flagship project. And I think getting together and sharing the education that I talked about in the 21st Century Truck Partnership has been very useful. We generally have at least monthly phone calls. People share what's happening, what's new, what are the issues that need to be worked on. But as Richard had pointed out, the funding from DOE has been focused more on the light duty because of the displacement of oil savings on the large number of light duty vehicles as opposed to the heavy duty vehicles. But I think we've talked in the 21st Century Truck Partnership with all the members of a flagship project such as a super truck, putting all these technologies together, aerodynamics, idle reduction, hybridization, start-stop, these things as one big package. It would be nice to have a moonshot for a truck, so to speak, especially on the Class 8 applications, which in fact could save a lot of oil.
Thank you. I yield to Mr. Inglis for 5 minutes.
Thank you, Mr. Chairman. First of all, Mr. Smith, thank you for Eaton having a facility in Greenville, South Carolina. We're very happy to have you there, and I'll give you an opportunity to give a plug if you want to about what you do there, especially if it relates to this, or even if it doesn't. But figure out a way to work that into an answer, would you? Is to do an advertisement for Greenville, South Carolina. I'm sort of wondering here whether we're doing science or economics. If it's science, it's holding us back to the deployment of these technologies, or if it's economics. The interesting thing about the economics is you can approach it a couple different ways. One is you can do grants and tax credits and regulate things, or you can unleash the power of the market. If you unleash the power of the market, it seems to me the first step is to stop having free externalities associated with the incumbent technology, which is diesel. If you attach the price to that, you internalize the externals to that product, then that 50% premium becomes a much smaller premium, right? Because then the freebie in the air that currently is and benefits the incumbent technology, which is diesel, shrinks. And as it shrinks, hybrids and every other kind of alternative suddenly becomes economically viable. Maybe not so suddenly, but it becomes economically viable. So which are we talking here? Are we talking science that's holding us back, or are we talking economics that's holding us back? Anybody want to tackle that yet?
In my opinion, it's both. I think there are some very short-term benefits that could be gained in this area, in my view, in plug-in technology. But those benefits are somewhat limited by not performing enough research. The research, in my view, could improve the performance over what is available today. I'm referring to different powertrain designs, which use smaller engines, larger electric motors, different battery technology that I have not seen available in a large capacity advanced battery for a truck. So I think it's a little bit of both. I think we could move very quickly if we had some research for specific applications and incentives. And then secondly, perhaps some research devoted to more longer-term advancement of the technology.
In what you're selling today, is the electricity used to charge the battery, which then runs the powertrain, or is it like the Chevy Volt is going to do? That's the concept of the Volt, right?
It's a parallel system, which means that the diesel engine is always operating when the vehicle is moving. And that's because, as Mr. Parish had talked about, in the industry right now, there is not a commercially available high volume electrification of certain subcomponents like the HVAC system, power steering, brakes, and so forth. So the engine is always running, and the electric motor provides supplemental propulsion. Okay, so there are limits to its efficiency gains because the engine is always running. The battery that we use is a very large battery. It's a heavy battery, but it's been around for a long time. That's why we chose it, because it's well understood technology. But it depletes. That means that you charge it up at night and you want the battery to deplete, and then when you're done after the day, you charge it up at night. That being said, this vehicle you never have to charge the vehicle up, because the system will monitor the state of charge of the battery, and the engine will turn on if it has to. But we try to eliminate, reduce that so that you can use grid power to recharge the battery.
Right.
So I hope that answers your question. It's using both diesel and the battery system to provide propulsion.
Is there an advantage to going to a system that uses only electricity for propulsion?
In my view, there is in certain areas. And I'm talking more about stop-and-go driving in urban areas. And perhaps in what I would call mission that has a job that has a short duration travel to a job destination that might be able to be performed under 100% electric operation for a limited range. Then when you're at the job site, operate off the battery power, and then return to the garage after the work is completed and charge up overnight using power from the grid. Right now, the battery power that we have is not sufficient, really, though, for that kind of application. I think more research needs to be done to provide that kind of power.
Mr. Smith, that commercial.
Yes, our Eaton Electrical Group down in your area.
Good.
But if I could just comment on with Mr. Dalum said, I think I would agree. It's a little bit of both science and economics. To your question, would it be better just to be all electric? I think that's a question, though, that you can't meet all of the needs because of the very wide range of applications that we're in. Clearly a heavy-duty Class 8 truck, you'd never be able to get enough storage capacity on a vehicle to do what it needs to do. Some of these work trucks travel far enough distances in any given day that, again, you couldn't store it there. But there are pickup and delivery trucks, like potentially a FedEx, a UPS truck. Depending on their duty cycle and where they run, you might be able to get into a situation where you could run that way. But the hybrid and having the ability to regen and recharge batteries on the vehicle, I think will always be a significant portion of the market, and you'll need that.
I'm sure the Greenville Chamber of Commerce will be most appreciative of your comments. I now recognize Mr. McNerney for 5 minutes.
Thank you, Mr. Chairman. I want to thank the panel. It's been a very interesting hearing, and it's an area that tremendous opportunity for our country. Particularly want to thank Mr. Parish for coming from Calstart. Calstart's working very hard to reduce emissions in the San Joaquin Valley, which is one of the worst air pollution regions in the country. So thank you, Mr. Parish, and Ms. Egbert for coming from PG&E, my home utility company. I think your comments on reducing emissions by 50 to 70% is very important, and that's something we need to keep in mind. Stockton, which is the largest city in my district, has now the highest gas prices in the country, surprisingly, considering that it also has the highest foreclosure rates. And we've seen a lot of hybrid technology on the highways with regard to private vehicles, but companies like BNSF are developing high-speed rail, not high-speed, but rail hybrid technology. So there's a lot happening, and it's very exciting to see it. My first question is about the battery technology. There's four things I'm concerned about. That's the cost of the technology, of course, the reliability, the life, and the disposal requirements for battery. Is that something, are they recycled, or could Mr. Smith or Mr. Dalum take that question?
Yeah, I can comment on it. The Eaton system currently is based on lithium-ion batteries, and yes, those are fully recyclable and can be handled safely in a end-of-life condition. I mean, there are several current sources in the U.S. where we can take batteries for appropriate disposal.
I spent much of my career in the manufacturing industry, and there is a law that every time you double your manufacturing volume, your cost goes down, maybe 10% or 15%. Do you expect that sort of law to apply? In other words, as we go up the manufacturing volume, are we going to see the cost go down accordingly? Or is there some inherent cost barriers that we're going to be facing with hybrids?
No, we definitely believe that we are currently, the price premium our customers are paying today is driven mainly by volume issues. As we can increase the volume of the components, we expect significant price decreases. It's all, it's what you've said, is we can drive up the volumes and get into higher volume, lower cost manufacturing processes. The cost will come out.
Is the battery technology improving in a way that will be parallel with the cost reductions or be contributing to cost reductions?
Yeah, what we see today, and again, Eaton Corporation has chose very early on to pursue lithium-ion batteries as the appropriate technology for these vehicles, and there's a lot of lithium-ion batteries for hand tools, but they're smaller cells, lower energy capacity. Those systems are already in very high volume manufacturing facilities, but the size that you need for vehicles hasn't made that transition yet. There's not the market demand driving that increase yet. So we're on that road, but we're not to the point where we can justify spending the money that you need into manufacturing facilities to increase the volume production and then ultimately get the lower cost.
Mr. Penney, do you have comments on the battery technology?
Absolutely. I was in Tampa at the International Battery Conference a couple of weeks ago, and as was said, the cell size are like C and D size batteries, and even for the Volt was mentioned. You're talking thousands of batteries and thousands of interconnects, and every time you have an interconnect, there's that potential for that string or module to go bad. Furthermore, as you package more and more batteries together for these heavy truck applications, you've got to worry about thermal issues. Thermal management of batteries, and something we at NREL have focused on, are very important. And then finally, there's the control. The Prius, for example, was mentioned. The state of charge in the Prius, you only use about a quarter of that battery because the state of charge swing goes from about 85% to 65% or 50%. So that's only a third of the capacity. On many of these duty cycles, and especially lithium, you can go from 90 to 10, 90 to 10. In a refuse example, they cycle that battery 1,000 times a day, or that ultracap. A battery can last maybe several thousand cycles, several million cycles, depending on that state of charge swings, the temperature, and actually the life. And the point is that all of these factors are unknown, and it's extremely difficult for these manufacturers to take the risk to say that this vehicle will last X number of miles and put a warranty on it. That warranty cost and that backing of that component is a very, very risky business at this point in time.
Thank you, Mr. Penney. My time's expired.
Thank you, sir. The gentlelady from Illinois, Ms. Bigger, you're recognized for 5 minutes.
Thank you, Mr. Chairman. I'm one of those people that was around in the 70s, sitting in the gas lines with 3 little kids in the back, thinking I was never going to get a full tank of gas again. And at that time, everybody thought that, and then suddenly all of this, the crisis ended and we forgot about it. The cars went back to being the SUVs and the heavy trucks and everything. And I don't think that that's going to happen again. I think that we really see that the world has changed and that we have got to reduce our dependence on foreign oil and gas and whatever. But my concern is that, we waited so long and we're still waiting. I think we've got the hybrid car. I have one. And yet the hybrid plug-in, to me, seems to be something that really is going, to change, I think, revolutionize the industry of both cars and trucks. But trying to, get the battery small enough and to last long seems to be taking quite a bit of time. And I think then if we're going to have the grid, then we have to have the nuclear power, which is going to, to create the electricity rather than some other type of energy. My question is then, maybe start with Mr. Penney. Is NREL working with the Army or any other branch of the military in the development of the hybrid truck technologies and bringing down the cost of the hybrid trucks?
Probably the intersection is through as was mentioned, the 21st Century Truck Partnership. We get most of our funding, as you know, from the Department of Energy. We get no funding from DOD or TACOM.
There was somebody else that mentioned the military, that Mr. Parish.
Yes. Calstart works with the military and gets some funding from the military to operate the Hybrid Truck Users Forum program. Obviously, we do feel like there does need to be further development in the battery area, specifically for medium and heavy-duty trucks. Right now, trucks rely on battery packs that were predominantly designed for light-duty vehicles. Even some of the buses that we see up in the Northwest in the Seattle area actually have Prius battery packs on them, these hybrid electric buses. And so what's really needed is some specific design of these battery packs for the medium and heavy-duty operation, and then a standardization of that battery pack so we can see the cost of the battery pack come down and be available to a wide variety of manufacturers.
Well, the military's been working on finding lighter weight material or metals for reducing the weight of tanks and trucks and whatever. Is the industry looking at that also? Like, let's say, titanium or whatever?
Yes, as a matter of fact, one of our participants in Calstart, Alcoa, is very interested in trying to identify new markets for aluminum and lightweighting of vehicles. And I think we're going to start to see that emerge more importantly here as fuel economy becomes more important for medium and heavy-duty trucks.
Will that dramatically reduce if we reduce the weight, then the battery will last longer, and would that aid in the development of the batteries?
Well, it's kind of an integrated problem. We have to approach it from a variety of different perspectives in order to get the total benefit that we're looking for. So reducing weight in heavy-duty vehicles, as well as increasing the efficiency of the battery packs, increasing the efficiency in the electrification of the auxiliary systems is very necessary. And then appropriate application of hybridization to the duty cycles of the vehicles is very important because there's a wide variety in the way these vehicles are applied, and so you get a wide variety of benefit from the hybrid system as a result of the duty cycle of these vehicles. So there's a broad spectrum of technologies that need to be investigated in order to be integrated appropriately. Also, downsizing and optimizing of the engines. Right now, hybrid trucks typically use diesel engines. However, the fleets are now very interested, fleets such as FedEx and UPS are very interested in seeing gasoline engines integrated.
You mentioned UPS, and I might mention that I do have an international truck in my district, and UPS has a big facility not too far from us, since everybody's claiming something in their state. But with that, how big is a fleet of the UPS with the hybrid trucks versus regular trucks? Does anybody know that? As we've been talking about them. Well, I'll ask them later then.
Well, they've just started incorporating hybrid trucks. I believe they have maybe on the order of 200 hybrid electric vehicles at this point in time. UPS is also investigating hydraulic hybrid vehicles, and one of our working groups is focused on bringing hydraulic hybrid vehicles to the parcel delivery segment. So they're just being implemented, they're being tested, but they need some improvements to really hit full stride.
Thank you. You're back.
Thank you. Mr. Sensenbrenner, you're recognized for 5 minutes.
Thank you very much, Mr. Chairman. First of all, I'll claim Mr. Dalum as a constituent since everybody's putting their oar in the water here. And I also was around when we had the gasoline crisis of 1979 and 1980. It was kind of my baptism of fire as a member of Congress, because they had this overcomplicated allocation system, and since I represented an area where the population was growing, the allocations were not enough, and the problems were more acute. And President Carter actually announced he was having the Bureau of Engraving and Printing print up gas rationing coupons. We saw pictures of them in the newspaper. Well, Mr. Carter didn't make it through the next election. President Reagan got rid of the allocation system. The gas lines ended. People were able to have full tanks. The price went down, and I don't know if the gas rationing coupons in the trash or not, but we haven't seen them, and that was about 30 years ago. Now, that's convinced me that technology is the way to get out of the pickle that we're in, rather than government regulation, taxes, and more red tape, and more congressional casework for our employees. Now, the bill that I have circulated around here establishes 5 grants for the development of plug-in hybrid trucks. In your written testimony, Mr. Penney, you state that there is no single hybrid truck design or system that will meet all of our transportation needs. And I guess my question I'd like to ask of all 5 of you in the remainder of the 5 minutes that I have is, are 5 separate grants enough to be able to have a specific technology developed so that one of these technologies would end up being suitable for the various types of trucks that are on the road? And since you brought the issue up, Mr. Penney, you can go first.
Thank you. You know, if you break down trucks into various vocations, as the class system tries to do, as I mentioned, each class, each vocation needs a different duty cycle. Just establishing and identifying and understanding that duty cycle is very difficult, and there probably are certainly more than 5. I think we identified maybe a dozen vocations which you'd have to focus in on.
Okay, that's asking a little too much, and the Sensenbrenner rule of legislation is he who sticks snout and trough too far runs risk of getting head chopped off. So I guess that the competitiveness in the 5 grants is probably necessary. How about you, Mr. Smith?
Yeah, I guess I would say that, you know, is 5 the right number? I guess I'm not sure. I think really what we need to look at is identifying the most likely paths to success, or the areas where we're furthest behind or we have the largest challenges.
But doesn't the competitive nature that's contained in the bill take care of that?
I guess I'm not sure. I need to review it a little bit further so that I could comment on that appropriately.
Competitive grants work very well, and most of the scientific grants that the federal government hands out, whether it's in basic science or biomedical research. Dalum?
I think it's an excellent start. The 5 grants, in my opinion, would allow a variety of different applications to be submitted, and I'm talking about technologies that might be, as discussed here, for delivery trucks, utility trucks. There's other applications I think that could be submitted that could benefit from plug-in hybrid technology, and those could also be part of that. So I think it's a very good start.
I would agree. I think it's a very good start as well. To start to get some of these technologies on the road and putting them into real-world applications, I think will bring us a long way.
Parish?
Well, from Calstar's perspective, I think we prefer to see a more general type of a funding activity and looking at medium and heavy-duty hybrids specifically or generally improving that general technology, with plug-ins being a subset of that general technology. So we feel that there's development work that needs to be done, but if we focus strictly on the plug-in aspect, that will just look at a very limited portion of the whole spectrum of the activity that needs to be approached. So, our feeling is that we would really like to see something more generalized than specifically plug-in.
Thank you. My time's expired.
I yield myself as chairman 5 minutes, and I yield to Mr. Sensenbrenner for him to continue his questioning if you'd like, Mr. Sensenbrenner.
No, I'm done.
All done? Thank you very much. Then I'll then let me ask, any of you would care to, or all of you if you want, are you aware of work being done to hybridize other sectors, such as heavy off-road work equipment, stationary power?
Yes. As a matter of fact, Calstart has just initiated a working group focused on commercial construction equipment, and that is also being sponsored by the U.S. National Automotive Center, U.S. Army National Automotive Center, because they're very interested in seeing, obviously, fuel use by their construction equipment being reduced. So what we've done is started some activity in bringing together the industry and the manufacturers as well as the users of this off-road equipment to see if we can stimulate some additional activity in hybridization. We've already seen Volvo initiate a front-end wheeled loader that's hybridized, and we expect other particularly U.S. manufacturers start to enter that as well. John Deere as well as Caterpillar have both expressed a great interest in off-road equipment hybridization.
Port of Long Beach, I understand, has a demonstration hybrid tugboat.
Yes, and they also are hybridizing the crane lifts for the containers. So we see hybridization starting to enter in a variety of different modes.
The primary thing that we're going to have to accomplish to facilitate all of that is going to be the battery.
The battery.
The length of the battery
and the auxiliary systems. We can't just look at one aspect, as Mr. Penney pointed out. If you look at just one component of the system, then you may not get the full story. You really need to look at the whole system effect and look at the variety of different things that are feeding into that system operation. So it's not only the battery, but it's an optimized engine that operates on the hybrid system. Right now, the engines tend to be a little bit too large for the systems they're actually running, so you have to optimize those a little bit better, plus the control. And then also the electrical auxiliaries. If you could get electrical auxiliary systems or hydraulically operated auxiliary systems, then that would improve even more the efficiency gains.
How long away are we from looking right now? And function of money that we have to throw at this to get faster results, get our end game more quickly?
Well, I think so. I think the first vehicles we've seen out there by Eaton and International, which PG&E is using, and a variety of other utilities are using, have shown the benefit of the hybridization. However, in order for the next generation to come out, we saw the first generation of Priuses back in 98. Then we saw the second generation of Priuses, which really mushroomed because of the improvements in the design. is we expect to see something similar in the medium and heavy duty truck category, where this first iteration that's come out, it's a great improvement over the conventional vehicle. However, there needs to be a second iteration, and in order to accomplish that second iteration, there has to be significant improvement in a variety of different technologies.
And industry is just not willing or capable to do enough of that by themselves without government help.
But I think they've seen a downturn in their sales they did last year as a result of the pre-buy for the 2007 emissions regulations. They're going to see another big pre-buy for 2010 emissions regulations. So right now, they're currently in a very low slump. I think this last year they were in a very low slump in sales, and so as a result of that, they were probably unable to spend the dollars that they wanted on research for hybridization. And now they're also spending quite a few dollars on getting ready for the 2010 emissions regulations. So that's what we're seeing is their focus on trying to improve their products for the emissions regulations, but because of that, they don't have adequate funding, I feel, to do the research necessary to bring hybrids along.
I'd like to pursue that some more, but let me switch. Just looking at the extensive membership list of Calstart, it would seem that the industry efforts are fairly well integrated when it comes to new technologies. How integrated is the heavy truck industry compared to that for passenger vehicles?
If I could comment, I think there's a fairly significant difference, because if you look at the pass car industry, it's mainly vertically integrated. There's a high level of oversight, design responsibility, integration responsibility that's all maintained within the companies, the Fords, the Toyotas, whoever it is. In the medium duty, heavy duty market, it's quite a bit different, where I think there's a view that they're buying components that go on the system. They're buying a transmission or a hybrid system that needs to integrate within the existing chassis with as little disruption to the chassis as possible. And I think the systems you see out there, I know the Eaton system, we intentionally try to make it as non-obtrusive to the engine and the chassis as possible. So there's some real challenges there because of the lack of heavy integration or high level of integration in the vehicle.
I would like to add that the vehicles that we're discussing are really, at least in the case of the utility truck, are built in multiple stages. And what that means is that an Eaton here may provide componentry to International, Ford, GM, or another chassis manufacturer. That chassis is then provided to another company. That company buys that and integrates their equipment on top of the chassis and finishes the manufacturing process and then brings it to market. So unlike some other passenger cars, you've got various entities along the whole development chain here and going to market. So it is not as integrated as a passenger car.
Just one more additional comment. What we found when we put the International Eaton bucket trucks out, those were the first hybrid trucks that were really on the road for commercial use. We found that there was some discord between the providers, as was identified, International, Eaton, and the actual arm manufacturer, in terms of who was responsible for what if there was a problem. So unlike in a light-duty vehicle, a Ford or a Chevrolet, where they are totally responsible for the vehicle, then because of the integration issues with a truck, it becomes then necessary to work out who is responsible for the operation of the different aspects of the vehicle. So this is one area where some further development activity needs to go on in terms to make everybody comfortable with the product that they're offering in terms of establishing who has ultimate responsibility.
Thank you very much. Mr. English, 5 minutes.
Thank you, Mr. Chairman. When it comes to basic science, grants seem to make a lot of sense. National Science Foundation, for example, does basic science, and there are no commercialization opportunities immediately apparent in a lot of that basic science, and therefore the government makes it happen by grants. When it comes to applied technology like we're discussing here, I sort of break out in hives at the mention of grants, because that means grant writers and grant readers, it means regulations and regulators, it means an awful lot of productive energy being spent pursuing just a little tad of money. It seems that there are some other ways to get there more quickly. One of them is tax credits, which, if you think about it, is a very efficient way to deliver a stimulus, because then you don't have writers and readers and regulators and regulations. But I wonder really what we're talking about here is mostly getting to the place where the incumbent technology is recognized for all the filth that it is. And if you do that, then suddenly everything else becomes more attractive. And then you have this incredible rush of creativity and innovation and jobs being created as we go out to take on that incumbent technology, which, by the way, is fueled by some people who don't like us very much. And so I would just wonder whether anybody sees it that way, or whether you want to make a spirited defense of a grant kind of system for applied technologies. I remember opposing in this committee. I didn't want to because I like her very much, but Ms. Giffords had a bill involving the installation of solar panels, training people to install solar panels. And I opposed that, and I lost on a vote about 20-3 or something. But I mean, it's the application of this principle. Do you really want to do applied work through grants, or do you want to use a more efficient way of getting to the market to respond? Mr. Parish, you want to respond to that?
Yes, and typically what we see, and I agree with you in that we need to identify what the real value of externalities are, because I think that would indeed help these alternative strategies become more viable. If we could monetize those externalities, that would make it even more viable. However, what we see in the typical development cycle or R&D cycle for new technologies is that the government funds the front-end R&D activity to get the basic science, to develop the technology, and that funding starts dropping off until it hits a valley of death, basically. So the industry is sitting there with a technology. They don't have the funds to bring that technology to market. And so that's one of the things that Hybrid Truck Users Forum does, is tries to aggregate the pull, the demand for that particular technology to get it out of the OEM and get it on the road. Now, we couldn't have done that without the support of the U.S. Army National Automotive Center, which provided us funding to not only run the working groups, but also to provide some upfront buy-down funding. And what we've also learned, so we feel that the government participation in trying to bridge that chasm is very important, because without that government funding to help bridge that chasm, the technology could very well just disappear and not be incorporated at all.
And we're here, though, not talking about, it's not a question of basic science here, right? If we were talking the batteries and battery efficiencies and things like that, that'd be more basic science. As it is, what we're talking about is the application of that to particular uses, right? And issues like warranties, which Mr. Penney, I think, mentioned. As I understand it, in the case of the Volt, that is a real issue, is the pricing of the Volt will be affected by the warranty that they've got to issue. And so working that out, which is really, again, more in the nature of economics and risk kind of allocation rather than science. The science of better batteries maybe could really change a lot of what we're talking about, right?
Right. There's a considerable amount of money being spent by the Department of Energy, through the Department of Energy, on battery development, but it is particularly focused on light-duty batteries. we feel that demonstration programs are a very important aspect of this activity, and the government has been involved in light-duty fuel cell demonstration programs, in particular light-duty vehicle fuel cell demonstration programs. And we feel like this is also necessary for the medium and heavy-duty sector as well. So it's really a three-pronged approach that we would like to propose is research and development, which talks about the science, what's really necessary to bring these advanced components into being. Number two is demonstration programs, so we can actually get the vehicles on the road and get people interested in seeing how they operate and seeing how they actually operate in service. And then number three, incentives to make the purchase. And what we found from the 2005 energy bill is that tax incentives do work for some segments, but not all segments. What we've seen is that for those who cannot take advantage of the tax incentives, they were able to be taken by the seller of the vehicle. However, that savings was not passed along to the buyer of the vehicle. So it didn't fulfill the role it was needed to at that point in time. So we'd like to see something that would be more of a rebate or something along the lines that would make sure that the end buyer, the end user, did in fact see the reduction in the cost.
Thank you, Mr. Chairman.
Ms. Biggert, you're recognized for.
Thank you, Mr. Chairman. I am concerned that we do need, that there's still basic research that needs to be done, and we haven't completed that. And that's, I'm concerned with the question that I asked Mr. Penney before, and still is what's preventing the DOE and the Department of Defense from collaborating. And I think that the public and the private sector would benefit from a collaborative R&D effort. But my next question then is there a role for universities and national labs to play in the competitive grant program created by the Sensenbrenner bill, maybe as research partners? And as I look at the bill, it talks about the 5 grants, and then it talks about partners, which include other entities, including manufacturers and electric utility companies. But I think that there certainly is a role for the labs and for the universities, which really the grant program would then pull the technology out of the labs and get the technologies into the marketplace. If we were to look at that, I would like, if anybody would like to respond to that.
Certainly, as Mr. Inglis pointed out, we need to work together, but at the same time, I don't want to waste my energy writing proposals for Eaton to send its proposal to get a thing, and then someone else comes to me, and I want our staff and our capability to be available to everybody, and I don't want to waste the energy and the money to have to use our staff writing proposals through competitive grants. Personally, for the lab point of view, we like to make ourselves available to all companies, and it's an open source, open knowledge, education, and work through competitive process, through non-disclosures, etc.
I don't think I was thinking of the lab as actually writing the grants or anything. It would be still but to be maybe a research partner that they would work with.
Right. But there has to be a flow of money, and part of the disincentive for Eaton, most of these grants or most of the programs are cost shared, 50% cost shared. We can't cost share. We can't use government money to, cost share government money funding. So as a result, it puts a burden, an extra burden on an Eaton or an international or a truck company to work with us or select us, because they have to come up with our cost share. So that disincentive needs to be taken away.
Mr. Dalum, you had.
Yes, in my opinion, the universities and national labs can play a role in this. I'm talking about testing, modeling, other types of activities that could help promote and improve the technology.
I know that Argonne Lab does have the Freedom Car that they do the testing for a lot of that.
Right, and there's other universities I'm aware of in Wisconsin that are working on hydraulics and other technologies that could be applied perhaps with research into this application.
Would anybody like to comment on the coordination between the DOE and DOD? Mr. Parish?
Yes, I think that has been attempted in 21st Century Truck. And I think, as I had stated previously, the vision of that particular activity was very good, and I think it was a good forum by which there could have been a greater amount of interaction. However, in actual practice, it didn't turn out quite that way. But, I think that given another try at it, there's a possibility that we could make that happen. I think perhaps with more visionary leadership and more stronger leadership for the 21CT, that would in fact happen. Plus, if we had some real funding that a consortium could work with to start identifying what real projects were viable, do some competitive grants for different aspects of the program, I think that would be very worthwhile. You could have different agencies looking at different aspects of the whole problem.
Thank you. Yield back.
Thank you for joining us. I want to thank everyone for taking the time to appear before us today, this committee. Under the rules of the committee, the record will be held open for 2 weeks for members to submit additional statements and any additional questions that they might have for the witnesses. The hearing is now adjourned. Thank you.